In this video, I want to look at the area between two curves with a second view. And I want to start by reviewing what we learned the first time we were thinking about areas between two curves. In the first video about areas between two curves, what we had was an xy view where we had a top function and a bottom function. And we were looking for the area between x is equal to a and x is equal to b. So we were looking for this chunk of area. And we found out that for a region that looks like this, the area could be thought of as the definite integral from a to b of the top function minus the bottom function. And basically what I want to be thinking of is this kind of a region is a top-bottom region, or it can be considered a vertical region, or it could be considered an integrate with respect to x region. They all mean the same thing, that when I am trying to figure out the things that I am integrating, I am basically drawing a line from the bottom function up to the top function. And that's how I know that I'm going to be doing go from the bottom to the top. So this line represents top minus bottom. What I want to look at in this video is integrals that get set up with respect to y and the kind of regions that they would correspond to. So let's now consider this kind of a problem. I want to have a region that is set up as follows. I'm going to have a function over here, and I'm going to have a function, I don't know, maybe it goes like this. And what I want to do is I want to label these functions in an appropriate way. This one is going to be labeled as x is equal to, well, it's on the right side, so I'm going to call it the right function. That should be right of y, though. And this other function, he's on the left, so we're going to call him x is equal to left of y. And as before, we're going to have a starting value. This is going to be y is equal to a, and we'll have an ending value up here, y is equal to b, and I want to find this chunk of area, the area between left and right, and over the interval as y goes from a to b. So I want to find that yellow area. Now, it should come as no surprise that this area should be a definite integral from y goes from a to y goes from b. The only thing is we need to figure out which of the two functions is playing the role of top and which of them is playing the role of bottom, since we're now looking at the world in a sideways fashion. So what I'm going to do is I'm going to understand that this is the positive direction for x, and consequently this is the negative direction for x. And so this side corresponds to the top in the x direction world, and this side is going to correspond to the bottom part of the x direction world. And consequently, to find this sideways interval, what I'm going to want to do is I'm going to want to integrate the right function and then subtract off the left function. So and these should be functions with respect to y. So let me get my variables right. So we're going to be looking at integrating right of y minus left of y with respect to y. And this is the basic formula for left-right regions. So this is called a left-right region, or you could think of it as a horizontal region, or you could think of it as an integrate with respect to y region. But in any one of the ways of thinking about this, the area is going to be integrate right minus left, because right is the thing that is on top and left is the thing that is on bottom if you are thinking in terms of y being the independent variable.